so now I'm going to talk about my second question for the optimization assessment, and it is the slant edge of a cone is 6 square root 3 meters. Find the height of the cone when the volume is a maximum, determine the maximum volume, and prove it is a maximum. So first I just drew a little picture for myself for the slant of a cone to be half the cone, and I determined my variables, so let h equal height, let r equal radius, and let v equal volume. So I knew my equation for volume for a cone was 1 over 3 pi r squared h. So on my side, I decided I want to solve for r squared. So I did r squared plus h squared equals s squared, and then to determine the sides, and then r squared plus h squared is equal to 6 square root 3 squared. So then I solved what 6 square root 3 squared is, and that was 108. So that means r squared is going to be 108 minus h squared. So for my equation then, I plugged in my r squared value, which ended up giving me the volume is equal to 1 over 3 pi times 108 minus h squared times h. So first thing I did was I multiplied the pi in, which ended up giving me volume v of h is equal to 1 over 3 times 108 pi minus pi h squared times h. Then the next thing I did was multiply the h in, which ended up giving me 1 over 3 times 108 pi h minus pi h cubed. So I wanted to see if what h was, and then to solve if it's a local max or a local min, and determine that and make sure it's a local max. So I took the first derivative, which ended up being 1 over 3 times 108 pi minus 3 pi h squared. So then by making that, which ended up giving me 30, when I multiplied the 1 over 3 in, I ended up getting 36 pi minus pi h squared. So next thing I did was then I made that equal to 0 and then solved for h. So I knew that since I took out pi, I had 36 minus h squared equals 0, which means that h is either plus or minus 6. But obviously there cannot be a negative value in a question like this, so that means it's just positive 6. So for this question I took a different route to see if it's a local max or min, and I did the first derivative chart. So I put in my value of 6 as my critical number, did a value smaller than 6 and a value larger than 6, plugged it into the first derivative, and I got that when the number is smaller than 6, that means it's increasing, and when the number is bigger than 6, it's decreasing, meaning that at 6 there is a local maximum, proving that this is a maximum value. Next, I want to solve for my r value, so I knew that r squared is equal to 108 minus h squared, and I knew h now was 6, so I plugged in my 6 and ended up getting that r is the square root of 72, which in decimals would approximately be 8.4. So then I just concluded that therefore the height would be 6 meters, and here it does say v is equal to when I'm determining the volume next, but it just doesn't fit in the frame. So the volume is equal to 1 over 3 pi r squared h, as I said before, and then I subbed in my numbers for r and h, and I did sub in square root of 72 here instead of 8.4, just so I would get a more precise value, and I ended up getting that the answer is approximately 452.38 as the volume, and though since the question doesn't really state if the volume is in liters or milliliters, I just wrote therefore the volume would be approximately 542.38 liters or milliliters, and that would just depend on the question since that unit was not given. And yeah, that is my answer for the second question.